Combinations at the ice cream parlor, a math story with five friends. The friends enter an ice cream parlor where they see a beautiful board saying 26 flavors from A to Z. And what is more exciting is that they can have a free sampler with three flavors. Wow, that is indeed exciting. We will answer four different questions with combinations in this video now. How many combinations of three can you make out of these 26 flavors? So, what seems like a simple choice is actually a beautiful math problem in disguise. With 26 flavors available and each sampler containing three different ones, how many sampler combinations are possible? Since the order doesn't matter, we use combinations, not permutations. Well, that is clear. If a flavor has ABC or ACB or BAC, these are all same. We have to divide by 3 factorial here since these three choices in any order doesn't matter, right? And therefore, we get our answer. So, how many samplers could there be where we need to take three flavors from 26 available flavors? It is combination. So now let's calculate the numbers. It's a combination of three flavors from 26 available. So the answer is 26 times 25 times 24 divided by 3 factorial or 6, and it gives us 2600. Wow, that's 2600 unique three flavor samplers. Now, based on this, let us have set of three questions for you to answer. Here's the first one. Carlos insists on having his favorite flavor C in every sampler. Now tell me, how many choices of samplers does it have? So now figure out the number of choices which Carlos has with C in every sampler. Well, since C is fixed, we are left with a choice of two others from 25 flavors. You see that? And therefore, it is going to be 25 times 24 divided by 2 factorial, which gives us 300 samplers. Clear, right? Here is the next question. Bela and Aryan want samplers with at least one of their top picks, A, B, or D. How will you calculate this? Well, one way to do is to find complements, which is we'll subtract the combinations that include none of these from the total number of combinations. Well, total we found are 2600. And those with A, B, or D, the three choices, will be out of 23, because 3 we have already taken, we have to choose 3. That gives us 23 times 22 times 21 divided by 3 factorial, which is 1771. Great. Samplers with at least one of A, B, or D will be 2600 minus 1771, which is 829. I hope that is clear. So the concept was from total number of samples, which is 2600, we take away those which do not have A, B, or D. So we know How many samples will have them? Perfect, 829. Here is the last question for you. All five friends want different samplers. We choose five unique combinations from 2600 total. Can you calculate this number out? Well, that's a huge number. A combination 2600, 5. A huge number, but this shows how rich the possibilities are. Math is everywhere, even in the choices we make for desserts. Understanding combinations help us appreciate the logic behind choices, variety, and real-life decision making. Crack the numbers, combinations made delicious.